Hello everyone. So today we're going to solve a random Leetcode problem, and to make it random I'm going to generate a random number from 1 to 1569, which is the 1569 is the number of Leetcode problems that exist as of today. We got the result 1193. So let's see what problem number 1193 is. 1193 does not exist. 1189 exists. So maximum number of balloons. So that's what we will be solving today. Let's see what kind of problem this is. Given a string text, you want to use the characters of text to form as many instances of the word balloon as possible. You can use each character in the text at most once. Return the maximum number of instances that can be formed. So you'll be given as you'll be given as input a text string text, and you want to make sure you want to be able to return the maximum number of balloon instances that you can build from this particular text. So in the example that you see here, NLAEBOLLKO, it becomes balloon like if we take this character, we have B, this character, we can take A. We're going to delete this character because we can only use one character 1. We can use L. We will use another L. We will use one O. We will use another O. We will use N. So we are able to make one instance of balloon from the given input. So the answer to that is 1, as you can see here. And just like that, if we get something like this, loon, balex, ball, POON, you can have 2 instances of balloon. And if you have something like Leetcode, then you cannot have any. Right, so what we want to make sure of is, if we have a text, we want to count the number of characters there are, right? So let's do one thing. We'll create a hash map of the number of characters in balloon. So map will look like B exists once, A exists once, L exists twice in balloon, but L occurs twice, and O occurs twice, N occurs twice. Now when we're going through the text, we want to make sure that it's a multiple of this. And how many times this is happening, right? So we will go through the text as well and build a map like that. Now we will go through balloon and see how many of that exist, and we take the minimum occurrences of that count. So if we get like that balloon B occurs once, A occurs once, L occurs twice, O occurs twice, N occurs once, right? Now we go through the text and we get something like B occurs 4 times, A occurs 3 times, L occurs 6 times, O occurs 8 times, n occurs 4 times. So what's the answer here? So when we get, then what we need to do is that we have one map, which is the balloon map, and then we have the text map, right? So then we need to loop through balloon, okay? So each character in balloon, and then we check what's the size, what's the current, how many bees can you build. You can actually build 4 bees, right? So right now our candidate answer is 4, because you can build 4 bees. We are probably going to get more, right? And then we are going to see that A, how many times can you build A? You can actually build 3 of that. 3 divided by 1 is 3, so the minimum of 4 and 3 becomes 3, and 6 by 2 is also 3, 8 by 2 is 4, but 3 is minimum, so we'll keep 3, 4 by 1 is 4, we'll keep the minimum. And if at any point this does not exist, looking up on B in text map does not exist, looking up on balloon map it exists, and it does not exist in text map, then we have a problem. So that's what we're going to do. We're going to keep track of 2 counts. So let's try and implement this. So we have in counts, this is always all going to be lowercase English characters. So ball map, that will be 26, and text map, that will also be 26. Now for each string ball equals balloon, and we're going to parse that string and take count of all the character occurrences in balloon. So counts of ball dot character at I minus a plus plus. So we have this, and we are going to do the same in the case of text. We have so much. So we have kept the map, right? Now we want to go through this again. So this is ball map, and this is text map. And what we're going to do is we will take the occurrences in ball OCC, ball occurrences in ball map of, well, let's first take the character in index equals ball dot character at I minus this. Now ball map of index, and int text OCC equals ball text map of index. Now if at this point we find that if text occurrences less than ball occurrence, then we can return 0 at this point. Else, now int min length equals integer dot max value. Now let's see. Int current possibilities equals text occurrences divided by ball occurrences. Now min length becomes math.minimum of current possibilities. I regret making huge variable names. Min length, and ultimately we can just return min length. I think this will work. Let's see if I have any compilation errors. Oh, that worked. Okay, let's try to submit this now. Yeah, so it works first time, and this is a pretty straightforward problem. So yeah, there's that. So thank you for watching. I'll be back with another video pretty soon. See ya.